Hello to all, welcome to my YouTube channel. Today we are going to discuss Euler's method. First of all, we check what is Euler's method. Let the differential equation be dy by dx equals to f of x comma y, where y equals to y naught at point x equals to x naught. We write it as our equation number 1. Next, suppose we want to find the approximate value of y, say yi, when x equals to xi. So divide the interval x0 to xn into n equal parts of width h, that means common difference is h, so that h is xn minus x0 divided by n. So integrate equation number 1 in xi minus 1 to xi, we get integrate yi minus 1 to yi dy, that is equals to xi minus 1 to xi f of x comma y dx. So in left hand side we integrate 1, so we get the value y, then substitute the limits yi minus 1, that is equals to xi minus 1 to xi f of x comma y dx. So this value become positive on right hand side. So yi equals to yi minus 1 plus xi minus 1 to xi f of x comma y dx. So we take it as our equation number 2. Next, suppose that f of xi minus 1 comma yi minus 1 is approximate value of f of x comma y in f xi minus 1 to xi. So this is our approximate solution. So this is constant. So equation number 2 becomes yi equals to yi minus 1 plus f of xi minus 1 to yi minus 1 integrate xi minus 1 to xi dx. Because this is approximate solution, so this becomes, we take it as outside. So again we integrate this value here 1, so that means we get x, substitute the limit, we get xi minus 1. So we get yi equals to yi minus 1 plus h, that means xi minus 1. This value is the common difference, so this value is h f of xi minus 1 to yi minus 1. So this is our Euler's formula to find the solution. So now we check how to apply Euler's method. So if we have dy by dx equals to 1 minus y with initial condition x equals to 0, y equals to 0, find the solutions for x equals to 0 0.1, 0 0.2, 0 0.3. So given dy by dx equals to 1 minus y, that means f of x comma y is given 1 minus y. So h is 0 0.1. Here h means common difference. So in these values the common difference is 0 0.1, and it is also given x naught is 0. So that means x1, that is x naught plus h, that is 0 0.1, x2, that means x naught plus 2h, that means this value is 0 0.2, x3, that means x naught plus 3h, that means this value is 0.3. So we apply Euler's method. y1 equals to y0 plus h f of x0 comma y0, and this is given in statement y is 0, that means this is our initial condition. So we substitute here y0 is 0 plus h is 0.1, and in function is f of x comma y, that is 1 minus y. So here that means 1 minus y0, that means 0. So we get y1 is 0.1. Next, y2. Again we apply here formula. y2 equals to y1 plus h f of x1 comma y1. So above we find the value of y1. Here we substitute y1, that means 0.1 plus h, that means 0.1. In function we put 1 minus y1, that means 0.1. So this is 0.1 plus 0.1 minus 0.01. By solving we get 0.19. So in this way we get y2 at the point x1. So next we find y3. That means here again we apply the Euler's formula. y3, that means y2 plus h f of x2 comma y2. We know that y2, that means 0.19 plus h, that means 0.1. In function we put 1 minus y2. y2 means 0.19. So this is, it becomes 0.919 plus 0.1, 0.81. By solving we get 0.271. So in this way we get y3, that is 0.271. So in this way we can apply our Euler's formula. Next is, what is modified Euler's formula? Modify Euler's method. First of all we apply the Euler's formula, then we get Euler's formula yi0, that is equals to yi minus 1 plus h by 2 into f of xi minus 1 comma yi minus 1 plus f of xi comma yi. So this is modified Euler's formula. So if we substitute I equals to 1, we get y1 naught, that is equals to y naught plus h by 2 f of x naught comma y naught plus f of x1 comma y1. So we, in statement y naught is given h, then f of x naught comma y naught, this is also given, f of x1 comma y1. So we find this value by Euler's formula and we substitute here, we get our answer in modified Euler's formula. Thank you so much. Hope you all understand Euler's formula. So if you have any doubt, then please write in comment section. Thank you so much.